All right, next we're going to talk about gears. A gear is not one of the 6 simple machines. Okay, but we're still going to cover it because it's really important, and it's one of those basic mechanisms that you will need to know next year, and it also helps you understand some things. All right, they're very much like a pulley. So if you understood pulleys, you'll understand gears. So you can see the big differences. There's no belt on here. The teeth of the gears actually mesh together. So they're actually a little more efficient than a pulley is. So you still have a drive and a driven. The drive is the gear that is turned by the outside effort, right? So you're turning the handle, you're applying effort. The gear that's being turned by another gear is the driven, so that's still the same. So you still need to understand the concept of drive and driven. The other part that I need to explain to you is the gear ratio. So instead of finding mechanical advantage, you are going to find the gear ratio. So if you look in this section, you are comparing the number of teeth on the driven to the number of teeth on the drive. So driven to drive, output to input. So if you look at the next paragraph, I give you a couple of examples. If a driven gear with 24 teeth is meshed with a drive gear with 48 teeth, driven to drive would be 24 to 48. So you're going to reduce that, right? Those are both even numbers. You know you can reduce both of those. This is where you get to use some math. Greatest common factor, 12. So 24 to 48 is the same as 1 to 2. So for every 1 tooth on the driven gear, there are 2 teeth on the drive gear. And it means that the driven gear will turn twice as fast as the drive. If you flip those numbers around, you will see driven has 48 teeth, drive has 24 teeth, 48 to 24 or 2 to 1. So in terms of speed, your drive gear is going to turn twice as fast as the driven. All right, so what does your assignment look like? You have 3 models to do. And again, this one is going to be really similar to how you did pulleys. You're going to calculate the gear ratio. In order to help you, I give you one of the gears and I put a red dot above one of the teeth so you would know where you were as you were counting, so you can count the teeth. Okay? And notice that those 2 pieces are the same, which is why you only have 1 picture, because they're the same. All right, so you're calculating the gear ratio. Make sure you reduce it as much as you can. Then you're going to turn the handle, or you're not going to turn the handle. You're going to watch the handle turn in the video. You're going to explain the speed of the drive and driven, like which is moving faster, the drive or the driven. And you're going to circle and label the drive and driven gears. You're going to have to put this in Notability. So if there are 2 different gears, I will give you the close-up of both of them so that you can count. Make sure you keep the numbers in the correct order. Just remember, driven to drive. What just happened to my page? There we go. So just remember, you are always comparing driven to drive. Driven to drive.